Hello everyone, welcome to this session. Yesterday in the previous session, we had a word about the basic overview of OTV, how OTV basic workflow looks like. We have talked about the different modes of operation for OTV, unicast, multicast. We have not talked about in details, but we have gone through the overview of it. We have also talked about how OTV is different from other tunnel protocols, let's say GRE or maybe Ethernet over MPLS or even BGP VPN with VXLAN. In this session, we are going to take a look at the OTV underlay. As I mentioned yesterday, that even though underlay configuration might not be significant to most of the clients who are trying to deploy OTV, because the underlay connectivity is going to be provided by the internet provider or maybe the MPLS provider, whoever is giving the basic IP connectivity, but it is still important and it is good to know how underlay is configured. And if you need to run OTV in the multicast mode, then what all things you need to have it there for the network to support the multicast routing. I have a GNS topology which we are going to work on here. If you look at this topology, the all these three zones, the green, blue, and yellow, these are representing three different OTV sites of a same customer. These devices that are in the edge, these are basically the edge devices, OTV edge devices, what we talked about yesterday. CSR 11 and CSR 12, CSR 11 and CSR 12. Basically, these to represent the two edge devices of site 1. Similarly, CSR 21 and CSR 22 for site 2, and CSR 31 and CSR 32 for site 3. The routers in between, that is in the white space, that represents your data center interconnect, which is basically giving the connectivity between all the edge devices. The way I have configured it is there is a separate process, OSPF 100, which is running for the intra-domain routing within the interconnect. And there is another process, which is OSPF 1, which is running with all these edge devices to CSR 11, 12, 21, 22, 31, and 32. And after that, I'm going to redistribute the routes from one process to other to make sure that I have basic IP connectivity from each CSR routers to other CSR routers on the, which means from one edge device to other edge devices. And we will go through that. We'll walk you through that. All right. So this is the ISP1, this is ISP2 and ISP3. If you look at this configuration, Ethernet 02 and Ethernet 03, these two are the interfaces on each ISP routers which are connected to the two edge devices of a given site. ISP1 connects to site 1, ISP2 connects to site number 2, and ISP3 connects to site number 3. Let's take a look at ISP1 configuration. Okay, you can see that I'm running OSPF 100. So OSPF 100 is the process which is running for the customer edge device connectivity. And if you look at the configuration of OSPF 100, I'm going to redistribute OSPF 1 subnets, route map, and routes to customer A. There is a route map associated with that. Let's see what we have there. This is show route map. I have a prefix list, show IP prefix list, routes to customer A. This network, what we have, the physical links that we can see between all the ISP routers and the edge devices, this all starts with 100 dot something. What I have done is when these routes are learned through OSPF1 process from each router, I'm going to redistribute that into OSPF1, which is my intra OSPF domain. But when I again route it back to OSPF1 here on this ISP1 router, because I'm not running OSPF1 process, OSPF 100 process between all the routers. So between all these routers, I'm running only OSPF1. So I had to redistribute these routes into here and with OSPF1 process. And then I also had to redistribute those OSPF1 routes back to OSPF 100. So that way my edge devices can get the routes for the remote edge devices. But at the same time, I wanted to make sure that whatever OSPF1 routes I have, which is intra-site, which is intra-DC interconnect network, I didn't want that to be exposed. So what I have done, I have configured a prefix list, which is consisting of only 100 dot prefix, which means these are the routes only going to the edge devices. I'm going to advertise only those routes to my edge devices. Okay. And if you look at my configuration for OSPF1, here, this is the configuration for my intra-site configuration in the DC interconnect. Here, I'm redistributing OSPF 100 completely. So OSPF 100 is again, this is what is representing your customer site edge device configurations, edge device routing protocols. So this is what I'm running between the ISP and the customer side. If you look at one of the customer side edge router configuration, this is CSR101, which is this router here, and the interface you can see it is gigabit 1. If you look at this interface gigabit 1 configuration, pretty simple. I have configured 101.11.11 IP OSPF network point to point and IP OSPF 100. Pretty vanilla configuration what I have. Now, if you look at the routes here, if I do a show IP OSPF route 100, you can see that I'm learning the prefixes for all the remote edge devices. So here, these all edge devices are running 100 dot prefix as I told you. So here 100 to 21, this represents the routes for connected to edge device CSR21. This one represents edge device 22. This 131 represents connection to edge device 31, and 32 represent the connection to edge device 32. So at the end of the day, what I want to make sure, if I am on this router CSR11, I want to ping all these. So this guy has IP of 21, this guy has IP of 22, 31, 32, 11, and 12, like that. So if I ping this guy, I should be able to ping that 100.1.21. Sorry, my bad, it is 2.21. I should be able to ping that. Similarly, I want to ping 2.22.22. Okay, let me make sure. I think maybe it is not configured. Okay, let me do this. I think CSR12 is not configured yet. Let me just confirm that. We will go to CSR. Let me make sure that okay, so looks like my secondary devices are not configured yet. CSR22, CSR32, in fact CSR12 as well. Let me try to log into those devices. Yes, this is not configured yet. So let me first try to configure CSR12. I will go to interface gigabit 1. I need to give an IP address, and this IP address is basically going to be 100.1.12.12. I'm running OSPF 100 for this process, which is connecting the DC with the edge devices. All right. My ISP devices configurations are already there for all the interfaces. So yeah, you can see that my OSPF came up. This is nothing but the connectivity between my ISP1 and CSR12. So now if I do show IP route OSPF, I should be able to ping the CSR21 and CSR31. Same for 31. Okay. Now we will go to CSR22, and similarly we will configure these two router as well, CSR22 and CSR32. Here the interface is gigabit 2, which is facing the ISP. The IP address should be 100.2.22.22. All right. I got an error message saying, okay, all right, never mind. All right, you can see that my OSPF came up. Now from CSR22, I should be able to ping CSR21, CSR11, CSR12, and CSR31. Okay, I'm sorry, this is not the right IP address. This is 100.3.31.31. Okay, so I have reachability to all these devices here. And now this is the last one, which is CSR32. This is also interface gigabit 1. Let me go there. All right. Now all these routers are configured. CSR 11, 12, 21, 22, 31, and 32. So all the edge devices are right now configured. And in the middle of the network, in the ISP, I already told you that I have configured two different processes, one for intra site, one for intra interconnect, and one for one to give the connectivity to your other site routers, OSPF 100 and OSPF 1. I have done some mutual redistribution between 100 just to make sure that these routes from this ISP 2, 3, and 1 are being exchanged to all the CSR routers and they know each other. And also I have done a route map on these interconnect routers to make sure that whatever routes are internal to the interconnect, that is not being advertised to the edge routers, because my edge routers do not need to know that. Finally, now all my routers are configured. So from here on, from CSR32, I should be able to ping all the edge devices. This is very important. This is the first thing you need to have to make sure OTV, you can configure OTV. Because if you don't have basic IP connectivity, OTV is going to fail. Let me try to ping the routers of site 1. Okay, now let me try to ping the routers of site 2. And now try to ping the routers of site number 3. Okay, you can see that everything is working fine. Now, one important thing is when you configure OTV, then OTV is going to add extra header, the shim, on all the packets. So you need to make sure that your transport has that needed MTU settings, what you need to need by your clients. So if your client is sending a packet of size 1500, then you want to make sure that you are configuring all your devices what you have in between, including this tunnel join interface with the MTU size that supports that MTU plus the OTV header, which is, I think, if I'm not wrong, 42 bytes. Basically, you want to make sure that you can ping between the routers with a DF bit of 1500, with a DF bit and size of 1500 to make sure that your traffic is going to get through. Because if that is not configured, then some of the applications which needs to send non-fragmented packets and which are sending 1500 size of packets, then those will be getting dropped, because when you are adding the OTV header on top of it, then it will be dropped by the routers in between, right? So this is very, very important. We have seen a lot of customers who actually encountered this kind of problems. So please make sure that your MTU in the transport is adequately configured to transfer your traffic. To be in the safer side, it is good to configure the MTU as a jumbo MTU, right? And of course, your ISP needs to support that as well, or whatever kind of transport you have in between, it needs to support that as well. But at the end of the day, you want to make sure that you can transmit the traffic of the required MTU size, the DF bit set to 1. So in our example, I have not configured jumbo because I'm not going to test with that. However, this is very important for any production network to make sure that they configure the required MTU settings in the transport part. So here, I think for me, just 1500 packets going to be good enough. So I can now run the same test from CSR32, whatever test I have run, with the size of 1500 and the bit 1. Okay, so you can see that I am able to reach 1.12.12 and also 2222. So I'm able to ping everything with a size of 1500 and a bit 1. But in my case, it is not set for jumbo MTU. But as I said, in the production network, you make sure that your MTU is perfectly all right. You might actually be want to ping the same IP address with a size of 1514 and the DF bit set to 1. In my case, I have not done that, but because I don't need to test it. But this is very, very important when you do it in the production. All right, so my unicast transport at this point of time is pretty much built, but this is not it. If I need to run OTV in the multicast mode, as I talked about that in the last call, in the last meeting, in the last session, then you remember that we also need to configure, make sure the underlay supports multicast routing. Now, if you look at this topology, this router CSR 11, 12, 21, 22, all the edge routers, they do not need to do multicast routing themselves. They are not going to route the multicast package here to make the OTV tunnel work. What you need is you need this routers in the middle, which means your transport network, it could be a ISP, it could be anything in between, whoever is giving you the basic connectivity, they need to support the multicast routing and they need to route your multicast packets to the destination. That is important. And that's the reason where most of the transit networks which do not support IP multicast routing, you need to switch back to the OTV unicast mode, which we talked about briefly in the previous session, and we will take a look at that in detail in the next couple of sessions. So that is the workaround. But for the multicast mode, it is a hard requirement. You have to have your transport supporting this multicast routing. In our example, we will configure ISP 1, 2, and 3 with multicast routing. And also we will configure ISP 1 as rendezvous point. We are going to run normal multicast asynchronous any source multicast mode is ASM, right? And also we are going to configure IGMP on these routers on the edge devices, because here when you are using the OTV, then basically your CSR routers, the edge devices, they are acting as multicast sender and multicast receiver. If it needs to send a packet to a OTV control group, multicast control group, basically it will be acting as a sender. And if it also needs to receive that, also needs to tune to that group, it will be acting as a receiver. So as long as your CSR routers are configured for IGMP and they can send the IGMP join and IGMP, they can send the multicast packets, they're good. But the routers in between, they need to take care of the routing part. So let's take a look at the ISP 1, 2, and 3 first to make sure that I have PIM enabled, I have RP configured, and this is completely set up to route my multicast packets from all the site routers. Okay, here is my ISP1. Um, the first thing I do is I need to configure IP multicast routing. These two are the interfaces, Ethernet 02, 03, and also 01 and Ethernet 00. I'm going to configure IP PIM sparse mode on all the four interfaces that we have here. Okay. Now on these two interfaces, Ethernet 02 and 03, I'm also going to configure IP IGMP version 3. All right, I'm going to configure my loopback as RP. All right, I'm going to copy this, do the same configuration on ISP 2 and 3, except the RP part of it. All right. So my ISP 1, 2, and 3, these are configured for basic multicast routing. I have configured ISP 1 as the rendezvous point, and also I have enabled IGMP version 3 explicitly on all these interfaces which are facing the edge devices here. Now let's take a look at what we need to configure on the edge devices, CSR 11, 12, 21, 22, and 31, 32. Here, I will go to interface gig 1 and I will configure IP PIM passive, and also I'll configure IP IGMP version 3. Similarly, I will go to CSR 12. All right, I'll go to CSR 22. For 22, this is interface is going to be gigabit 2. And then for 32, this is again going to be gigabit 1. All right, I will also need to go to CSR 21 and CSR 31 to make sure that these interfaces are configured as well. So if I go to CSR 21, interface gig 2, IP PIM passive, and IP IGMP version 3. If I go to CSR 31, it's going to be 1, IP PIM passive, and IP IGMP version 3. All right, so pretty much that's all I need to configure this multicast here. Okay, and let me go back to the diagram here. So at this point of time, my multicast is the network is ready for multicast to route the packets. Now, when we bring up the OTV tunnel on these routers, edge routers, we will see that how the entries are built on the routers in between, which is on the interconnect, and how exactly the MRoute table looks like. But That's pretty much it from what you need from the underlay perspective. Now, one important thing also you need to do, we will take a look at that now, is you need to configure the routers here in between, and you need to configure this all the edge devices in between here. So these are actually the core devices of each side. These are basically doing all the routing, and but by layer 2 is extended all the way to the CSR routers, which are the edge devices. I will configure one of them so I can show it to you, and then I will configure the other routers in the middle so you don't need to look at the same configuration again and again. Uh, Here on this core switch 1 and core switch 12, I will configure two VLANs, VLAN 11 and VLAN 22. I'm going to do the same thing on all the other routers, all the core switches here on different sides. And I'm going to configure these two interfaces here, Ethernet 00 and Ethernet 01, one for VLAN 11 IP address, one for VLAN 22 IP address. So basically this host I'm simulating here, this router I'm simulating here as the end host with two different NIC cards, one in VLAN 11, one in VLAN 22. My end goal will be to ping from this host router here in VLAN 11 to VLAN 11 on the remote side, and then from 22 to 22, and also the inter-VLAN routing, which is from 11 to 22 and 22 to 11. Okay, so let's take a look at that part now. All right, let me go to this router, which is the host router. I'm going to configure Ethernet 00 for VLAN 11 IP address and Ethernet 01 as VLAN 22 IP address. Ethernet 01 I'm going to configure with VLAN 22 as IP address. Just to make sure my inter-VLAN routing and I have configured the gateway, what I'm going to do is I'm going to configure IP route 192, 123.11.0 with a default gateway of, let me put this IP address 254 as the default gateway IP address, 192.123.11.254. We will play around a little bit when we are trying to basically do the inter-VLAN routing. For the time being, I'm just putting this IP address here, but it doesn't really mean that we need to, this will, we need to actually walk around that a little bit. I will explain later on. Uh, what I'm going to do now is I'll go to core switch 1, but but basically what we have done here is, if I show you, these are the two interfaces I configured. This is like two different clients I have, one in VLAN 11 and one in VLAN 22. That's it. That's it. Then I will go to core switch 1 and core switch 2, which is basically these two routers in between, these two switches in between. Core switch 1, and also need to go to core switch 2. All right. Uh, in this diagram, you can see that I have three interfaces, gigabit 01, 02, and 00. 02 is going to be my access port because this is what I'm going to simulate as a host port. So let me go to interface gig 02, switch port mode access, switch port access VLAN 11, and spanning tree port fast. Okay, I'm doing a no shut. I'm creating VLAN 11 and VLAN 22. These two VLANs I'm creating. These two interfaces, gigabit 00 and gigabit 01, I'm going to configure them as simple trunk port. Okay, I'm going to configure VLAN 11 as a root bridge as switch 1 as a root bridge, and I'll configure switch 12 as a root bridge for VLAN 22. I'm also going to configure layer 3 interfaces on both these switches, and I'm going to configure HSRP here. Similarly, I'm configured for VLAN 22. I'm sorry, I give the wrong IP address. It should be 22. All right, I'm just going to copy and paste this configuration in a notepad so I can put it in switch number 22. Sorry, switch number 12. All right. So here also let me create the VLANs. I'm going to configure gigabit 2 as an access port. And other two ports I'm going to configure as trunk. And here is my interface VLAN 11 and VLAN 22 configuration. So the basic idea is, and we will talk about one important concept which we already have in the agenda, which is FHRP filtering. We want to localize your FHRP, which means that I want to have my HSRP active and standby localized to each site. So which means I'll have one HSRP active router in this site one. I will have another HSRP active router in site number two, and I'll have another HSRP active router in site number three. That is the idea, because if you don't do that, if you actually pass the HSRP packets across the OTV tunnels, you might be seeing that one of the site having HSRP active router, which means if you have a client which is in VLAN 11 and VLAN 22 in the same site, if they need to communicate, then the packet needs to go all the way to the other site and needs to come back to get routed between the two VLANs, which is not quite optimal design. So that's the reason we want to make sure that we are localizing the HSRP, VRRP, or GLBP, whatever protocol we are running, the first of redundancy protocol we are running. We need to make sure that we are we are localizing that. So that way we can do optimal routing. And again, we need to do some additional filtering for that. What we will look into that later on. But as of now, what you can see, I have configured HSRP on these two routers. Similarly, I will configure HSRP on the other site routers as well, which is core switch 22, 21, and core switch 31 and 32. I will give the same IP address. I'll give the same standby IP address. But again, how to localize this, we will look into that later on. So that being said, that's the basic configuration what I need. Now, in order to make sure that this VLAN 11 and VLAN 22 is extended all the way to CSR routers, we will need to configure something on those edge devices as well. And we will take a look at that in the next section. So in the next section, we're going to take a look at how the CSR 11, 12 routers need to be configured, both for the LAN ports and also for the overlay ports. We will take a look at that in detail. So thank you for listening to me. We'll come back soon in the next session. Thank you.